Okay, we're going to write this equation. It says write the slope-intercept form of the equation when it has a slope of 13.9 and it passes through a point 915. So we can use this the point slope formula, which you can memorize. Where x1, y1 is a point on the line, and m is the slope. Well, the slope we're given, so we can say 13/9, and I only use one point no matter what, so I'm going to use 9/15. X is 9 and 15 is y. So I'm going to put in a 9 here and a 15. And it wants it in slope-intercept form, so that means they want to solve for y. So let me just go ahead and distribute this. So 13 times 9 divided by 9 would be 13. And I'm going to add 15 to both sides. So I get 13/9 x plus 2 is equal to y. And this is called slope-intercept form. And you could also do it by solving for the y-intercept. Some people do this. So this is a different method if you like this. You put in your slope that you're given or that you calculate for m. And you replace your x and your y with your point. So 9 and 15. And you solve for b. Once you have b, you rewrite your slope-intercept equation, but this time you replace m with your slope and b with the y-intercept you just solved for. And this would be your equation. So you can do it either method. Our next equation also wants us to give the slope-intercept form, but this time they gave us 2 points. They're always the same method. You're going to find the slope and a point. Okay? So our slope is given as y2 minus y1 over x2 minus x1. And one of my students said it makes her think of 2 martini glasses on a picnic table. So hopefully that helps you remember the visual of the y's go on top. Now, you want to label your points. Every ordered pair has an x and a y. And you want to just choose which one you're going to call point 1 and which one you're going to call point 2. Let's just call this one point 1 and this one point 2. And that's what those little subscripts mean. So I always, when I'm evaluating formulas, I put parentheses wherever the variables are. So y2 is going to be -4. y1 is going to be 2. x2 is going to be -4. And x1 is going to be -8. So this will be -4 plus 8, which is 4, which simplifies to -3/2. So this is my slope. So in the last problem it was given to us, this one you had to calculate it. But we always just need a slope and a point. So you're going to choose a point. I'm going to choose -8, 2, but you could choose whatever you like. And I'm going to use it in my point slope formula that we did earlier. And I'm going to replace my slope for m. And I'm going to put my point in here. Now notice I put parentheses again to remind me that I'm going to put the value for x1 and y1. And this will become x plus 8. So now if it wants it in slope-intercept form, I have to solve for y. So I'm going to distribute this, and this is going to become -3/2 x, and then minus 3 times 8 is 24, divided by 2 is 12. And if I add 12 to both sides, oh, that's a 2. If I add 2 to both sides, I'll get -3/2 x minus 10 is equal to y. Now, if you use the other method, if you're a person who solves for b and uses the slope-intercept method, you still calculate the slope the same way. And then you just choose your point. We're going to assume you choose the same point, so -8 for x. and y is b, and y is 2. So negative 3 times negative 8 is 24, divided by 2 is 12. So b is negative 10. Now you use the b and the m and you write the equation. So y is equal to negative 3 halves x minus 10. Same answer, just a different way to get there. You may choose whichever way you like. The next question says, which is more convenient to solve this with substitution or elimination? Well, we want to use elimination when the variables are stacked nicely over each other. We want to use substitution when we solve for one of the variables or could easily solve for it. So since x is already solved, I'm going to choose substitution. The next problem is a word problem. Troy and Lisa were shopping for school supplies. Each purchased different quantities of the same notebook and thumb drive. Troy bought 7 notebooks and 9 thumb drives for $206. Lisa bought 13 notebooks and 11 thumb drives for $274. Find the cost of each notebook and each thumb drive. So the question, whatever we're looking for, these are our variables. So let's call the cost of each notebook N and the cost of each thumb drive D. So we're going to use now our information to set up 2 equations. So 7 times N plus 9 times D is 206. I get this from my very first piece of information. And then I use my second piece to write my second equation. So 13N plus 11D is 274. And now you can use whatever method you like to solve this system of equations. So I've multiplied my first equation times negative 13 and my second equation times 7. Okay? And then the reason I'm doing this is to eliminate the n variable. I've created 2 new equations and I can add these now, and I've eliminated, this will become 0. Okay? And this will become negative 40D. And this will become 760, and it's a negative 2. So I'll divide both sides by negative 40. Get that D is 19. Now D is my thumb drive, so it would be $19. Now, once I get D, I always have to send this variable, the solution, back into the original equation. So I'm going to say 7 times N plus 9 times D. But in place of D, I'm going to write 19 is equal to 206. Okay, and I'm going to solve for N now. And I go ahead and solve this, and I get N is equal to 5. So a notebook costs $5, and a thumb drive costs $19. And typically, I go back in and check both equations to make sure that these original equations are satisfied. This problem is very similar to the one we just did.